Greetings to all the viewers. The session is going to cover the international intermediate chemistry, national level JE advanced JE mains chemistry for NIT and IIT admission, NEET exam, medical entrance intermediate chemistry will be covered. Telangana and Andhra Pradesh EMCET BTech admission entrance examination is also covered over. If government organization aspirants, government job aspirants are there, their general studies question paper and general science content is available. That is also covered in today's session. Let's go with the question number 1. The Royal Swedish Academy of the Sciences has decided to award 1992 Nobel Prize in the field of chemistry to the Professor Rodolph A. Marcus, California Institute of Technology, Pasadena, California, United States of America. Right. So he is the scientist accorded with the prestigious world recognition Nobel Prize in the year 1992 for his contributions to the theory of electron transfer reactions in the chemical systems. Right, how electron transfers are carried in the chemical system, that was accorded with the Nobel Prize in the field of chemistry for the year 1992. Here is the research advancement, what is carried actually, what is laureated for this Nobel Prize. Professor Rodolph A. Marcus is being rewarded for his theoretical work on the electron transfer work, which has greatly stimulated experimental developments in the chemistry. He framed the hypothesis and the theoretical assumptions were made by him. Later on, it found the multi-dimensional applications in the field of chemistry. That's the reason why his work was accorded. The process Marcus has studied the transfer of electrons between the molecules in the solutions underlay number of exceptionally important chemical phenomenon, and the practical consequences of his theory extend overall the areas of chemistry. Whatever he framed, that is called Marcus theory, that was extended to the various fields of chemistry irrespective of its branch. Right, the Marcus theory describes and makes the predictions concerning such widely differing phenomena as a fixation of light energy by green plants, photochemical production of the fuel, chemiluminescence process, which is also called as a cold light, the conductivity of electrically conducting polymers, corrosion process, methodology of electrochemical synthesis, and analysis more. So it is not the part of a single domain. Rather, he go on with the assumptions in the so many fields. One is about how the light is fixed by the green plants, how they are consuming the light, how food production is possible. That is one assumption. And photochemical production of the fuel by means of light induced chemical reaction, it is possible to synthesize the fuel. That is another assumption he made. Chemiluminescence, by using chemical reactions, some glowing tendency will be observed, which is called chemiluminescence. So that is also called as a cold light, that phenomenon introduced by the Marcus theory. And conductivity of electrically conducting polymers. Polymers are the compounds which are having exceptional ability to conduct the electricity. That assumption also made by this Rodolph A. Marcus. Corrosion process, deterioration of the metals by means of environmental interaction, that process is also assumed, that process theoretically given by this scientist Rudolf Marcus. The methodology of electrochemical synthesis and analysis. Electrochemical synthesis is nothing but inducing electricity and chemical reaction together to carry the chemical reactions, and analyzing the path of reaction, in what way they are proceeding. That kind of assumptions were made. Multi-dimensional research approach was done by Rudolph A. Marcus. From the year 1956 to the 1965, Professor Marcus developed his theory for what he perhaps the simplest chemical elementary process. So simplest methods were introduced by the scientists so that where the electron transfers are possible. All these reactions are proceeded with the shifting or transfer of electron from one medium to another, one system to another, one component to another. This is the way transfer of electron plays a role in all these processes. No chemical bonds are broken, such as a reaction. Rather, just we are shifting or transferring the electrons from one element or one molecule to the another molecule. So molecular structure of the reacting molecules and their nearest neighbors, we are not going to change them. This molecular change enables the electrons to jump between the molecule. Electrons are supposed to move from one region to another region without making any kind of cleavage of the bonds, right? So this is the way a theory is a closure to the reality, though it is a theoretical one, but it is implementable experimental evidences later on given for the Rudolf A. Marcus theory. Professor Marcus found simple mathematical expressions for how energy of the molecule system is affected by these changes, right? Energy of the molecular systems are affected by the changes whichever provided. With these, he was able to calculate and explain greatly varying rate measured for electron transfer reactions. Okay, what is the rate of reaction? What is the speed of electron transfer? Entire or rate of the reaction for these kind of electron transfer reactions. In the mathematical connection, Marcus theory makes between the theoretical and experimental quantity. Whatever theoretical quantities are provided, they are experimentally verifiable. That extent of validity we have, so that they are recorded with the prestigious world recognition. Experimental chemists gained a valuable tool by this electron transfer theory. The theory has proved a useful interpretation of many chemical phenomena. Okay, this can be extended further to the so many processes. Even though it was initially controversial, certain predictions are proved, experimentally verified, so that experimental confirmation later on carried after this 1980s onwards, so that it is universally accepted theory called Marcus theory. Here is the brief demonstration regarding the Marcus theory, where electron transfer reactions got carried. The distance between the donor acceptor, electron transfer becoming more efficient. The optimistic distance is required so that electron transfer is more easy to carry in between the donor and acceptor. The Gibbs free energy with the electron transfer becoming more efficient, reaction is becoming more exergonic. Okay, so the feasibility of the reaction is carried based on this Gibbs free energy. So reaction with the Gibbs free energy, electron transfer is more efficient. So that Gibbs free energy also the part of this electron transfer reactions. Recognition energy caused incurred by the molecular rearrangements donor acceptor medium during the electron transfer rate is predicted to increase as this recognition energy is matched closely by the reaction Gibbs free energy. Whatever experimentally carried that practical value and theoretical value is comparable values we obtained, so that this electron transfer theory is universally accepted and is accorded with the world recognition called Nobel Prize for the year 1992 in the field of chemistry. And we entered into the question 2 collected from the Cambridge International Assessment. The structure of the 4 organic compounds are provided. All are hydrocarbon skeletons only. In the compound 1, you can notice the double bond. In the compound 2, hydroxy functional group is there. And compound 3, simply hydrocarbon. It will be of all the single bonds. And here you can notice the bromo functional groups on the alkyl chain. So if this is the condition, we have to answer the questions whichever poised here. Decolorize the aqueous bromine. Aqueous bromine can be decolorized wherever double bond is there. And saturation only you can notice in the option, compound C, so that we can go with this compound C as the answer for first question. Alcohol means hydroxy compound, where hydroxy is there, but that is the part of alcohol. So this is the D will be the answer for question number 2. Unsaturated, wherever either double or triple bond is located, that is a part of what? Hydrocarbon. So that C is the right answer for this question 3. Same homologous series in the ethane. Homologous series is nothing but any two compounds which differed by CH2 unit. As we are extending CH2, alkyl chain length gradually increases. That is called homologous series. Whenever you are taking ethane, that is alkane, as we are extending CH2 moiety, so that we can extend with this E, compound E. This is the way all the questions answered and the suitable answers are provided. Aqueous bromine can be decolorized by unsaturated compound over there. This is the identification test for double or triple bond presence. Hydroxy compound is present in the compound number D, and unsaturation is there in the option, compound number C, where you can notice the double bond. Presence of pi bond is called unsaturation. And here you can notice simple homologous series of the ethane extended with the 2-methylene, and you can find a butane as the product. By this, we conclude the question number 2. Let's go with the question number 3 collected from 2014. JEE Advanced Question Paper, Paper 1, National Testing Agency conducted all across India. This is a question collected from the physical chemistry part and gaseous state it will be. An ideal gas is a thermally insulated vessel. Insulation means what? Either heat will neither go out nor enter inside. It is completely insulated one. Internal pressure is denoted with the P1, volume is given as a V1, absolute temperature is T1. Whenever expand irreversibly, again is zero external pressure. We are not applying any external pressure, so the pressure remains constant. As shown in the diagram, the final increase in the pressure, volume, and absolute temperature are designated as P2, V2, and T2 respectively. At that condition, what will be the suitable answer we need to predict? So let's go with the answer for this. Since vessel is thermally insulated, so insulation means heat neither go out nor enter inside, so that Q will be 0. Q will be 0 is the answer for this one. And at heat change, if 0, work done will become 0 as well. So that work done 0 is not provided over there, so that that is not required. Internal change difference also become, when heat change is 0, absolutely internal energy change will become 0 for free expansion. At that condition, T1 is equal to T2. T1 is equal to T2 is also the correct answer for this one. Means we are not having any internal energy change, so that whatever initial temperature is there, after the expansion also that remains same. T2 will be that. So that P1, V1 is equal to P2, V2. Except option D, A, B, C are the correct answers. Let me repeat one more time. Being it is an insulated vessel where heat change will be 0, so that work done will be 0, so that initial temperature, final temperature remains equal. B is also correct answer. At that condition, initial final temperatures are same. P2, V2 is equal to P1, V1. A, B, C are the correct answers for question number 3. So, wrong answer will be P2, V2 to the power gamma is equal to P1, V1 to the power gamma. Except this remaining A, B, C are the correct answers only. All are mentioned clearly in this explanatory part. So if two temperatures are remains same, so that we can say isothermal. Isothermal means temperature remains constant, called isothermal. Volume remains constant, called isochoric. Pressure remains constant, called isobaric. Where here you can notice temperature constant, that's why isothermal process it will be. So this is the way A, B, C are the correct answer. D will be the wrong answer for this question number 3. Let's go with the question number 4, where 2014 paper 1 JEE advanced question paper we collected, and this exam conducted by the National Testing Agency. Hydrogen bonding plays a central role in the following phenomenon. Hydrogen bonding is possible whenever elements are in contact or are in the comparable distance in order to form the dotted line bond. The elements, only 3 are able to give the hydrogen bond are, one is fluorine, oxygen, and another is about nitrogen. Except these 3, no other element in the periodic table is able to form hydrogen bonding. Let me repeat. Fluorine, oxygen, nitrogen are able to give the hydrogen bonding whenever polarizable hydrogens are present in the near vicinity. Whenever ice floats in the water, obviously water is existing in the liquid form, that is because of the hydrogen bonding only. If water is not having that cohesive hydrogen bonding, always it exists in vaporized form only, just like H2S. So H2S, sulfur, oxygen, both are belongs to same family. Here hydrogen bonding will be there, so that here ice floats in water is accompanied by the hydrogen bonding. Higher Lewis basicity of primary amines than the tertiary amines in the aqueous solution. Higher Lewis basicity of primary amines than the tertiary amines in the aqueous solution. That is purely because of, in both the cases, amines are composed by the nitrogens only. But basicity of primary amines are higher in comparison to the tertiary amines. Why? Because tertiary amines are sterically hindered one. All are sterically hindered, so that hydrogen bonding formation is very difficult because of hinderedness. But in case of primary amines, they are free for formation of hydrogen bonding where cohesive forces are possible. Hydrogen bonding is located in the primary amines very conveniently, so that they are Lewis basic in nature. They are giving electrons by hydrogen bonding formation. Formic acid is more acidic than acetic acid. Here we can't explain this one. Here the electronic factors plays a role, like what inductive effect, mesomeric effect, electromeric effect. These fundamental rules are operated in the formic acid acidity in comparison to the acetic acid. We will go with the inductive effect in particular in order to explain this one. Formic acid, all are having, if you compare formic acid and acetic acid, both are able to give the hydrogen bonding. There is no question for the absence of hydrogen bonding, being both are made up of oxygens and hydrogen, so that both are existing, both are operated with the hydrogen bonding only. Based on that, we can't justify which is stronger acid, which is weaker acid. This can be explained by means of inductive effect, electromeric effect, mesomeric effect, like that. Okay, so that we can strike off option number C. Go with the option number D, dimerization of acetic acid in benzene. So in water, it will not be dimerized. It is monomeric in nature. Rather, acetic acid will be dimerized in benzene. How can we explain this? Benzene is a non-polar solvent. No, there is no electrical charges. We can't notice any charged species over there. So that acetic acid is made up of what? OH and OH in molecules, which are more convenient to form the hydrogen bonding, so that it existing in a dimer form. Because of that dimer form, they are accompanied like this. But in case of water, that is not dimeric, rather it is the monomeric. Why? Because there is a possibility of acetic acid to form the hydrogen bonding with water. Water is also polar, acetic acid is also polar. There is a provision for what we can say intramolecular hydrogen bonding. So acetic acid, when dissolved in water, the provision is in intermolecular. Intermolecular means outside of the acetic acid, that table. Intermolecular hydrogen bonding is played in water. Intramolecular, within the molecule themselves, they able to form the hydrogen bonding. That is possible whenever benzene taken as a solvent. Right. So this is the way all are mentioned with their hydrogen bonding. Here, obviously, hydrogen bonding for the dimerization, that is intramolecular, we can notice. So let's see the detailed explanation regarding this. Option 1, ice has a cage-like structure. Ice having, though it is solid in nature, low density, so that it will be floating. It will be floating on the surface of water because of hydrogen bonding only. Again, here the most important part we need to know is there is a kind of caged structure you can see where the halo cavities are located because of hydrogen bonding. If hydrogen bonding is not there, all the water molecules are cohesive, closely arranged, so that high density, so that ice will be suspended at the bottom. Rather, ice molecules got hydrogen bonded like this. Whenever hydrogen bonds are there, bond distance is greatly increased. That are all those are giving the cavities among, so that certain extent of distance is maintained in case of that ice. So where the density they're occupying the larger volume, so the density values of that ice will be reduced in comparison to the water. Always ice floats on water. That is the reason or because of hydrogen bonding. And go with the next compound, amine. Amine, upon treating with water, what it will do? Obviously, protonation of this amine is possible. We will get ammonium cation and the hydroxide will be generated. They are in contact with the hydrogen bonding, so that it is able to it is able to it is able to explain that hydrogen bonding, giving its basicity, taking this bond like this. So that is because of hydrogen bonding, primary amines are possible. But in case of tertiary amines, there is also the existence of lone pair will be there, but this bulky alkyl group is not allowing nitrogen to give the electrons. It is it is stopping the release of electrons because of occupation of the entire space around the nitrogen atom. So the tertiary nitrogen is not that specific, that is to release the electrons to this water to form this kind of salt form. So that hydrogen bonding is less prone in case of tertiary in comparison to the primary, so that primary amines are more basic in nature in comparison to the tertiary amines, purely relying on the hydrogen bonding. We can clearly explain. Let's go with the formic acid and acetic acid. Formic acid, acetic acid, both are able to form hydrogen bonding, so it is not the point of explanation for that acidic strength. Rather, Plus effect. Just now we explained about inductive effect plays a role for the comparison of stronger acidic nature for formic acid in comparison to the acetic acid. Why? Because in order to release the H plus, carboxylate should be formed. That carboxylate carboxylate if it is in contact with the methyl. In case of acetic acid, we can find methyl group over. That methyl group is having plus I effect. That methyl is releasing electrons to carboxylate. No, so carboxylate is becoming electron rich. Whenever it is becoming electron rich, it will not tends to lose the H plus. Because already it is having sufficient electron density, no? So that plus I effect, because of plus I effect, acidic strength of acetic acid is lower in comparison to the formic acid. So this is the way we can explain the option C based on inductive effect rather than the hydrogen bonding. Next is about hydrogen bonding is possible for acetic acid as a dimer, that is intermolecular hydrogen bonding is possible, and a benzene solvent, that is a non-polar solvent. A, B, D are the correct answers. We gone through, C is the wrong one. We concluded question 4. Let's go with the question number 5. Which of the following are not aromatic? In order to follow the aromatic, certain rules should be fulfilled. One is about plenarity must be there. All the carbons should lay in the sp2 hybridization, and that must be a closed ring type of system. And most importantly, Huckel rule must be followed. 4n plus 2 pi electron system should exist in the compound. Then only we can say the given compound is aromatic in nature. Which are not obeying all these rules are regarded as not aromatic compounds. If you go with compound 1, where you can see 5-membered ring with the 2 conjugated, and must be all the pi electrons are in conjugation. And here you can notice 2 pi bonds are in conjugation, and here negative charge. Cyclobentadienyl anion, where 6 pi electron system is there. These two and this electron also contributed for delocalization, so that it is a 6 pi electron. It is the part of aromatic. If you go with compound 2, if you observe here, one of the carbon is sp3, here one of the carbon is sp3, and moreover there is no conjugation. In both the cases it is violating the rules, so that you can strike off this is non-aromatic. Go with this tropylium cation, that is called cycloheptatrinyl cation. Let me repeat. Cycloheptatrinyl cation is called tropylium cation in general, where all 3 pi bonds are in conjugation, and it is the kind of ring type of structure, and this carbon is also the part of sp2 hybridized. So that's the reason why 6 pi electrons with sp2 hybridization, ring type, and conjugation is there. Everything got fulfilled completely, so that it is aromatic. Go with this one. Here it is a kind of angular type of one rather than a linear. Both the kind of positional isomers are possible. So this is a part of what polyannular aromatic compound. Polyannular aromatic compound called phenanthrene, where you can find all the pi bonds are in conjugation, all the carbons are in sp2 hybridization, all are laying in the plenarity, all are having what? 4n plus 2 pi electron system. Everything got perfectly satisfied so that it is aromatic. Go with this one. If you go with this cyclopentadienyl cation, you can find a conjugation, sp2 hybridization for all carbons and ring system. But Huckel rule will not be obtained. Huckel rule is violated because we are not having 6 pi electron system. Only 4 pi electrons are there. You can strike out. This is the non-aromatic. And go with this. You can find this cyclopropyl propenyl anion. Cyclopropynyl cation is aromatic. Rather, cyclopropynyl anion is non-aromatic. Why? Because this carbon is sp3 hybridized. Carbene intermediate giving rise to sp3 hybridization. So that this is also not the part of aromatic. So this is also taken as answer. B, E, F are the correct answers that are mentioned in option 2. For question 5, option 2 will be the right answer. Let me go with the last question of the session, question number 6. How many of the following compound shows the ferrimagnetism? Ferrimagnetism to be defined as ferrimagnetic substances are the compounds with the magnetic moment domains are aligned parallel and anti-parallel directions. Either parallel or else anti-parallel will be there. That is in an unequal number. All are not. So if you see the parallel spin are 4 in number, anti-parallel are in 2 in number. So that unequal number of parallel anti-parallel description will be there. That is called ferrimagnetism, right? So that how many compounds are having that ferrimagnetism from these? Fe3O4, MgF2O4, NiF2O4, MnO, CrO2. All these are the oxides of transition metals only. Iron, nickel, manganese, chromium. Transition metal oxides were found. For these ferrimagnetic substances to be identified. క్రింది వాటిలో ఎన్ని సమ్మేళనాలు ఫెర్రీ అయస్కాంతత్వాన్ని ప్రదర్శిస్తాయి? Okay, the correct answer will be 3. How can we say 3? Let's see. The net magnetic moment is small. The net magnetic moment is not becoming zero, rather it is infinitesimal. That means a very little amount of magnetic moment will be there. Compensation will not be there, right? Because it is unequal in number. Thus, weakly attracted by the magnetic field. Being a magnetic moment is less, their attractive forces towards the magnet will be less only than the ferromagnetic. Ferromagnetic of highest strength. Ferromagnetic substances are having highest strength, but ferrimagnetic are having lowest strength towards the magnetic field. They also lose ferrimagnetism upon heating. Being it is an infinitesimal quantity, upon rising the temperature, even that extent of magnetic field also lost. And they are converted into paramagnetic in nature. Okay. The compounds Fe3O4 and ferrites like zinc, iron oxide, magnesium iron oxide, nickel iron oxide are the part of ferrimagnetic in nature. So given options are Fe3O4, magnesium iron oxide, nickel iron oxide. Fe3O4, magnesium iron oxide, nickel iron oxide. These three are the part of what? Ferrimagnetic substances. So correct answer will be option number 3. By this, we concluded the entire session and new content is introduced over, and definitely it will be informative session who are serious about the examinations. I'm sincerely requesting to like the channel, and in order to comment, can you please categorize diamagnetic, paramagnetic, ferrimagnetic, ferromagnetic substances, anti-ferromagnetic substance. I'm mentioning 5 types. One is about diamagnetic, paramagnetic, ferrimagnetic, ferromagnetic, anti-ferromagnetic substances based on their magnetic moment. That can be answered in a comment box for the session, and share with their parents who are more curious about the examination, and subscribe the channel. We will definitely come up with the new content in the near future. Thank you all for your consistent listening. Thank you one and all.